Happy New Year, kids. We are moving on to our next chapter, which is chapter 6, and it is all about quadrilaterals. So if you remember, hopefully, a quadrilateral has 4 sides. So we're going to be talking about different polygons, which is just a shape that have 4 sides. Your note should look like this. Angles of polygons is our first lesson. A lot of this chapter I think you guys will really enjoy because it's we talk about like squares and rectangles and trapezoids. I think a lot of it is kind of prior knowledge, but then we just kind of add our own little flair to it. Okay, so after today's lesson, you will be able to find missing angle measures of polygons using the interior or exterior angle sum formulas. So today all we're doing is finding missing angle measures. Okay, this diagram is not in your notes, but I just kind of want to show you how we get one of our formulas, okay? So if we look here, obviously our smallest polygon, smallest in terms of number of sides, I should say, is a triangle. You need at least 3 sides to make a polygon. So our smallest sided figure, or the least sided figure that we can make, is a triangle. We have 3 sides there, obviously. We can only make 1 triangle out of those 3 sides. And we already know that the angles of a triangle all add to 180, right? So now we're just going to keep going through our list here. Okay, a quadrilateral has 4 sides. And then if we look here, we draw on this diagonal and we split that quadrilateral into 2 triangles. So how many degrees are in a quadrilateral? Well, 180 times 2 is 360. Now a pentagon has 5 sides. And then if we look here, we can actually split that pentagon into 3 different triangles. So now 180 times 3 is 540. And then so on. We'll do one more. A hexagon has 6 sides. And if we look here, we can split that hexagon into 4 triangles. And now if we take 4 times 180, we're going to get 720. So you see this in math, you guys remember, everything's just a pattern. And our job is kind of to figure out what our pattern is to make our life easier. Otherwise, we have to do this long process every single time. So let's say we have some random number of sides. So we're going to call it an n-gon. It doesn't matter if there's 10 sides, 8 sides, 30 sides, whatever it is, n-gon. We don't need to draw a picture for that, but we know there's n number of sides. Well, what's the relationship between the number of sides and the number of triangles? So if you notice, if you have 3 sides, we had 1 triangle. If I have 4 sides, we had 2. 5, there was 3, 6, and 4. There's 2 less, right? So if I have n number of sides, I'm going to have n minus 2 triangles. And then to get the sum of those interior angles, we take this number, whatever it is, and then we multiply it by 180. So we just figure out what our formula is for the sum of the interior angles of our polygon. So again, the n equals our number of sides. I'd probably write that down. And then, because that's how many triangles would be in our shape, times 180. And this is going to tell you how many degrees are in our polygon. So let's try a few examples using this idea of finding the sum of the interior angles of a polygon. So our first example says find the sum of the interior angles of a 15-gon. Don't overcomplicate it, kids. It's literally just calculator work. We have a 15-gon, so that means I have 15 sides. Minus 2 times 180. So all I did there, so I probably should have wrote this first. Sorry, kids. It's been a while since I made a video lesson. Here's our formula. Plugged in 15 for n, because that's how many sides we have. And now we just simplify. So 15 minus 2 is 13. 13 times 180 is 2,340. So all the angles inside that 15 gon have to add to 2,340. All right, now we are looking for this missing angle here in this polygon. So there's a few steps to this problem. So our end goal is to figure out what this angle measure is. So in order to do that, we first have to figure out what do all of these angles inside this shape add to? Well, let's first figure out what kind of a shape do we even have here. Well, we have a 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon, right? So now since I know I have 8 sides, we're going to plug into our formula to figure out what all of these have to add to. So here's our formula. Now we plug in 8 for n, so 8 minus 2 times 180. So 6 times 180 gives us 1,080. So now, again, all 8 of these angles in here have to add to this 1,080. So now all we have to do is subtract all 7 of these angles to see what's left over for our missing angle x. So what I'm going to do is I'm going to add up. I'm going to take a second, add up all 7 of those angles on in my calculator. You should do the same just to make sure I am doing this correctly. So I get, when I add them all up, 936. So now subtract that away from our 1080. Get 144. That is the value of x. Okay, now we're going to shift gears just a bit. So now we're going to talk about the interior angle of a regular polygon. So let's review real quick. Remember, a regular polygon is one in which all sides are equal. Therefore, all of our angles are equal. So if we want to find just one of our angles in a regular polygon, this is what we do. We take the total sum of what all of them have to add to, and then we divide by the number of sides, right? So if you think about it, if we have say we have a square, right? Because we know a square has all 4 sides the same, which means all of our corner angles are the same. Well, we just learned that a quadrilateral has 360 degrees in it, right? And then we're going to divide it by 4, the number of sides it has, which is 90. And that's telling us all of our angles inside here are 90 degrees. Okay, so this formula is only used when you have a regular polygon and you're only looking for one individual angle. Okay, so you take the sum and divide by the number of sides. So now we are being asked, it says, what is the measure of each interior angle of a regular pentagon? So it's really important that you pay attention to what the question's asking. We're just looking for what one measure of each angle of a regular pentagon. So let's plug in here. Here's our formula. We know a pentagon has 5 sides, so let's plug in 5. And now we just simplify, folks. So 5 minus 2 is 3. 3 times 180 is 540. Divided by 5 is 108. So each angle of that regular pentagon measures 108 degrees. It's going to be a really bad drawing. Okay, here's my regular pentagon. So each of these angles in here measure 108 degrees. That's what we just found. Now let's see if we can work backwards. This time, we are told, it says the measure of an interior angle of a regular polygon is 144 degrees. We want to find the number of sides it has. So this time we know what the angle equals, but we don't know how many sides there are to this polygon, and that's what we're trying to figure out. So we're still going to start with that formula, but we know it equals 144 because we know the angle measure inside is 144. So now our job, oops, sorry kids, is to figure out what n is. So this is just algebra. Don't overthink it. We just got to algebra our way out of this. So I want to get rid of this fraction. I don't like working with fractions. I bet you don't either. So to get rid of divide by n, let's multiply both sides by n. So now we're going to have n minus 2 times 180 left on the top. These n's cancel. Equals 144 n. Now from here, I'm going to distribute my 180 to both of those. So I have 180n minus 360 equals 144n. And now you have a problem you're used to seeing, right? We want to get our n's to one side and our numbers to the other. So let's see here. If I subtract 180 n over, we're going to have negative 360 equals negative 36n. Divide by negative 36, and we should get n equals 10. So we just found that a 10-sided figure has an interior angle measure of 144 degrees. Do you guys remember what a 10-sided figure is called? It's a decagon. All right, we're switching gears again. So we were just working with interior angles, but now we want to talk about exterior angles. And what's really nice about exterior angles is no matter what your shape is, no matter if it's 3 sides or 50 sides, it's always, always, always 360 degrees. There's no formula. You just need to remember that they equal 360 degrees. So let's find the value of x in this picture here. So I hope we can all agree that all of these angles in this example here are on the outside of our polygon, right? They are formed by extending one of our sides of our shape. So these would be considered exterior angles. And we just talked about that they need to add to 360. So we are going to take all of these, add them together and set it equal to 360. So I'm going to kind of do a couple steps in one. Let's add our like terms as we go. So 1x plus 1x is 2, plus 2 more x's is 4x. And now let's add all of our constants together. Let's see here. 2 plus 10 is 12, plus 88 is 100, plus 52 more is 152. And we just said they equal 360 degrees. And now we have a very simple linear equation to solve. Subtract over your 152. We're going to get 4x equals 208. Divide by 4, x equals 52. That's it, folks. Not any more complicated than that. Then our last example for notes today, it says find the interior and exterior angle of a regular hexagon. So remember, a regular hexagon means all sides are the same, meaning all of your angles are the same. So let's start with the easier one, exterior. We know that all 6 of those angles have to add a 360. So if I want to find just one, let's take 360 and divide it by 6. And we find that it is 60 degrees. And there's actually a pretty cool relationship that an exterior and interior angle have. I'm going to go back to this example here for a second. Do you guys see that your exterior angle and your interior angle form a linear pair, right? All of these. Do you guys see how we have a linear pair at all of these different intersections? I moved my arm. Sorry, kids. So that means they add to 180. So if we know either our exterior or our interior, you can find the other one by subtracting from 180. So if our exterior angle is 60, if we subtract 180 and 60, we find that it's 120 degrees. I realize this is a lot of information for one video. I also realize there's a lot of different examples, and we went through it quick. So if you're a little lost, don't worry. Tomorrow we'll do a bunch of desk examples together, and we will make it more concrete if this was a little quick for you. Can't wait to see you, and have a super rest of your day.